Right. Good afternoon, everyone. I hope you can hear me. All right. Good afternoon, Mr. Lanita. All right. I've seen some response. Thank you, Mr. March, and thank you, Mr. Lapo and Palubu. All right. So straight to the class. Today we'll be looking at microservices architecture and say preface or the prelude. Of course, we desire to the aim of any software engineer. All right. I hope you can hear me. Now, I think yeah, can you hear me now? And can you see my screen? No, okay. I don't know what happened. I think stuff just appeared. Um, so I said as a prelude that microservices, okay, that's the end product of any software project is to produce a product called a software, which should be delivered to the end users, right? Or a particular end user or the person who commissions the project. Now, software, of course, it's a very is a monolithic and they are products that are several parts, different things interacting here and there. And it's just like the human body system or the different parts. We have the head, the heart, the legs, the skin, the tissues, the bone, everything linked together. Now we have different, all these aspects having to get blood pumped by the heart to them. We have different aspects having oxygen pumped by the lungs to them. We have ultrafiltration by the kidney, the liver, and some other part of the body. So this gives a lot of work to be done by just one system servicing the whole body parts, right? So I remember while I was in secondary school way back, our biology exams was on ultrafiltration, and I think the what we used for practicals was the glomerulus, I think, which was responsible for filtering of our urine and waste products. So what microservices does in general is to zero in, right, on a particular service to a particular area where the distance that it has to cover to do its work is not too far from where it is located. So everything around it can be easily managed, right? So that is generally what microservices is all about, right? It helps us to collocate simple tasks that can be done without interfering with the whole general software or the whole part of the software, right? That's even if there's a change on it, the change is going to be minimal, and it won't affect the whole system that we have got or that we have produced. Now, of course, the practice, because everything we are doing now, we are trying to make it targeted towards a particular solution or doing a particular job. For instance, if we need to get what's the name? So like we have in the programming paradigm, we have concepts like procedural programming, right, where you have procedures and functions for different modules of the program. Now that became quite cumbersome. Then we decided to go object-oriented, or we go to object orientation, where we represent different classes with different objects, and just to make our programming easier. Now, instead of you having to write classes all the time or define objects all the time, why don't you make it service? So we went to service-oriented programming. You have libraries that you could just pull and plug into your code. So instead of writing the whole libraries by yourself, you just write a simple cPNET that just calls the library to run in your code, right? So, and it goes on and on and on like that. So we are moving towards a situation where we have if a whole function being performed by just a snippet of an algorithm or a program, right? So these are the things we are running towards, even in software development. So what is software services or service? So a software service is a software component that can be accessed from remote computers over the internet. Given an input, a service produces a corresponding output without side effects to the generality of the program. So the service is accessed through its published interface, and all details of the service implementation are hidden, right? So all you need to interact is with the interface that is presented to you, right? Then nothing is really affected or in the whole of the program. So for instance, you are provided with a screen that, okay, supply your name. That's all you need to know. What happens in the background is for the programmer to decide. So services do not maintain any internal states. State information is either stored in a database or is maintained by the service requester. Now, when a service request is made, the state's information may be included as part of the request, and the updated state information is returned as part of the service results. Now, you may request for a service to be sent to you, right? Now, you are querying a database. Now, maybe while you are querying a database, maybe close to you, another person is querying that same database. In order to avoid inconsistency in database management, the service you have created, the microservice you have created, has a portion that says, okay, this was my state when I was making this request. What is the new state? Do I need to update the database before I also put on my results, right? I'm sure you'd have done that in database management. Now, there's no local state. Services can be dynamically relocated from one virtual server to another. And if there is an increase in demand, replicas can be created across servers to carry out the job that you need to do. So modern web services. So after various experiments in the 90s with service-oriented computing, the idea of big web service emerged in the early 2000s. Now, these were based on XML-based protocol, and standards such as SOAP and for service interaction, and WSDL for interface description. So most software services don't need the generalities that is inherent in the design of web service protocols. Consequently, modern service-oriented systems use simpler, lightweight service interaction protocol that have lower overhead and consequently faster execution. So what we are driving at generally is to have fast execution, fast requests, and fast return of results. That's what we generally want to look at or want to achieve in creating services that are closer to themselves and also related to themselves in some ways. For instance, you have a family. I don't get what you say. Overhead. Overhead means cost of processing. So I hope you get what I've just said. Yeah, somebody just asked a question in the chat. I just responded. So microservices. See? Okay. So microservices are small-scale, stateless services that have a single responsibility. They are combined to create application. Now, just as I opined earlier, when I was talking about the human body, that the human body has several parts, right? And they perform different functions. For instance, the brain performs the duty of coordination. The heart performs the responsibility of pumping blood around the body, the lungs for getting the air, oxygen, yeah, sorry. Getting oxygen around the body. The kidney performs the body of filtration or for filtration. Well, I'm not sure what the liver does, but I think probably it also does some things on this detoxification, right? The legs helps carry us about. The skin helps protect us from ultraviolet rays, and the melanin on it also helps us to cope with the cancerous tendencies, right, that the sun will cause in this part of the world. But it's unfortunate that we have a number of people bleaching up their skin melanin just to meet up with societal pressures, or you want to get somebody who's light-skinned, right? So different parts of the body perform different functions. However, each of these organs can be studied independently, right? And one of the examples I said was the glomerulus, right? Its function is to do ultrafiltration of water in the body. And it is located in the, I think in the kidney. So instead of us having poisonous water recycling our body, the glomerulus help us filter it out, right? In order to make our system function effectively and well also, right? So microservices is just like studying a particular organ, then looking deep to look at, okay, just a little microcosm of this whole big thing, right? How can we have just a segment of it that can be well defined to do a simple work or a simple task effectively enough, and it doesn't disturb the whole process. Now, for instance, assuming that you want to sleep, right? And you find all your organs working and just disturbing inside you, I don't think you'll be able to sleep, right? So in a way, we can hibernate some of these organs. Like you find that your heart rate reduces, your skin gets cold so that the temperature of your body reduces. Then the I think what's even what works when you're sleeping, just the filtration that works when you are sleeping generally. So also with microservices, they are completely independent with their own database and UI. Now, UI management code. So software products that are microservices have a microservice architecture. Now, if you need to create cloud-based software products that are adaptable, scalable, and resilient, then it is recommended that they are designed around a microservice architecture. So let's look at an example of a microservice. One of it is system authentication. So you have user registration, you have authentication using UID or password, two-factor authentication using code sent to your mobile phone, user information management, reset forgotten password. Each of these features could be implemented as a separate service that uses a central shared database to hold authentication information. However, these features are too large to be microservices. To identify the microservices that might be used in the authentication system, you need to break down this the coarse-grained feature into more detailed functions. So you may have a feature, for instance, feature like print. If you need to print a document, right? So you could break print into different microservices. For instance, when you select print on a MS Word document, you have different options, maybe print, maybe one, I think, is it one page, or the document on the page, or maybe one per page or two per page or something like that. So breaking it down into further details, for instance, you want to print in grayscale or in color, you want to make it fast draft, normal, or think excellent or best. So each of these little details are microservices of the class print, right? So it's just like it requires a lot of well, let me not say a lot. For some people, it may be a lot of mental work, right, for you to get some of these things broken down into fine grains or coarse grain that could be microserviced, right? Now, however, these features are too large to be microservices. To identify the microservices that might be used in the authentication system, you need to break down the coarse grain feature into more detailed functions. Now, we have the user registration. You have set up new login ID, set up new password, set up password recovery information, set up two-factor authentication, confirm registration. Now, authentication using UID or password could be broken down into this, further into these little grains or coarse grains that are closely connected by getting login ID, get passwords, check credentials, confirmation. So can we break down each of these features into microservices? For instance, set up new login ID. Can we further break it down into microservices? Set up new password. Can we break it down into further microservices? Set up two-factor authentication. Can we further break it down, which has been done here? Now, confirm registration and so on and so forth. So this is authentication for microservices. You have authentication, you have UID management, password management, user information. So it's just like you have a pool of things there, then you classify them into what they are closely related to. Now, in one of the simulation, okay, I think we're doing theory of computation. So we wanted to use mathematical model to represent a farm, right? So we defined the number of, we looked at, okay, what kind of animals are present on the farm? So we define that we have two legs animals, then we have four-leg animal. Then we give the number of the two-end animal, the two legs animal, and the four-legged animal. So we had to develop a mathematical model to represent the total number of animals on the farm, and then to also break them further into the total number of two legs and the total number of four legs. So this is the first kind of classification. Two legs means that they are eaves, yeah, or chicken, all those things. Then the other ones may be mammal, working mammal, except human anyways, maybe animals. So when you the first set of classification you do is to classify them into two legs and four legs. Then you could go for that, okay, and two legs, chicken, turkey, parrots, any of those things. So the first thing is to get the whole big class, then start breaking them down into bits and bits and bits until you get to a neatly formed micro service. So these are the characteristics of microservice. They must be self-contained, they must be lightweight, implementation independent, independently deployable, then of course, they must be business oriented. So how does microservice communicate? Microservices communicate by exchanging messages, right? So let's look at the glomerulus I made mention. Once, what the glomerulus does is that it gets the whole whatever that has been passed to your kidney, it gets a message of dirt or plenty molded up things. It gets into it, it filters it into, it removes toxins, yeah, I think they call it toxins. It removes toxins from the whole food you have eaten, the everything, water. Then it sends the good one back to your system and it throws the other one out for you to pass, right? So what it does that it gets a message of what needs to be filtered. It does a particular work, filtration. It sends back a message, which is pass this back to the body, remove this from the body, right? Okay, I think there's a question here also. Standing. Okay, every time I think some of you will just I didn't tell you to write your name, and I'm going to fish you out and throw you out. I don't think you're going to write this exam too. And be disturbing my life all the time. Just a minute. All right. So next time, write your name. I'll throw you out. I don't need to start explaining to you again. Where did we stop? So microservices communicate by exchanging messages. Now, a message that is sent between services includes some administrative information, a service request, and the data required to deliver the requested. So can we say microservices are also modules performing related functions? Well, I think somebody just asked a question. Now, just as we saw in the introductory part, that some features may be too big to be microservice. For instance, if you write a module to solve a particular problem in a domain, now you will find out that module can have different functions. For instance, print is a module, right? But in print, you could have different simple tasks that can be done. So if you have a module that has simple tasks that can be done, then we cannot generally say that that is a microservice. So microservice return a response to service request messages. Now, an authentication service may send a message to a login service that includes the name input by the user. The response may be a token associated with a valid username, or might be an error saying that there is no registration for that user. Now, if an individual's kidney is damaged, then the response by the glomerular is that kidney damage filtration cannot be done, right? Now, I'm not saying that what I've painted is generally microservice as it were, right? Because some people in biology may have things even more finer, more fine-grained of what the glomerulus does than just that ultrafiltration. So microservice characteristic. So a well-designed microservice should have high cohesion and low coupling. So what's cohesion? Cohesion is a measure of the number of relationships that parts of a component have with each other. High cohesion means that all of the parts that are needed to deliver the component's functionality are included in the component. Coupling is a measure of the number of relationships that one component has with other components in the system. Low coupling means that components do not have many relationships with other components. So each microservice should have a single responsibility. Okay, I think let me see, what's that question? Mr. Debayo. Okay, so he said each microservice should have a single responsibility. It should do one thing only, and it should do it well. However, one thing only is difficult to define in a way that is applicable to all services. Now, responsibility does not always mean a single functional activity, right? So, for instance, we have a password management functionality. So you have user function, you have create password, change password, check password, recover password. So to check your password, supporting functions that could be linked, they should have at least some kind of relationship with other functions. So supporting functions, you have check password validity, delete password, backward password database, recover password database, check database integrity, repair password DB. So these are supporting functionality for each of these micro services or services. So microservice support code. So this microservice X, you have a service functionality, you have a message management, failure management, UM implementation, data consistency management. So architecture, a microservice architecture is an architectural star, a tried and tested way of implementing a logical software architecture, right? This architecture style addresses two problems with large applications. Now, the whole system has to be rebuilt. Now, that's the problem of that's the large software, where you have different functions, you have different scenarios, you have different stories, all encompassing, all the maybe addressing the user's need, right? So you find out that this whole system has to be rebuilt, retested, and redeployed when any change is made. So if you have any change, everything has to just be retested and everything. Now, this can be a slow process, as change to one part of the system can adversely affect other components. Now, you find out that, well, I don't know, if you plug in your system on the internet for a long period of time, now you see it will automatically look for some updates, especially if you have preset it that you should not install the update without your knowledge, so that some malware will not just creep into your system. So you just have when you want to shut down, or probably you just see that a pop-up comes up on your system and tells you that you should shut down your system in about maybe 5 minutes or so, that some update needs to be effected. And you are still working. How would you shut down my system when I have almost 200 application open? So you can shift it, continue to shift it until one day it gets tired and decides to start shutting down forcefully. Now, this has disrupted the whole process that you were doing before now, and may cost you a lot of things, right? So that's one of the components of having a very big, one of the problems, right, that the architecture of a big software has, that the microservice architecture is trying to address. So as demand on the system increases, the whole system has to be scaled, either scaled up or scaled down. Even if the demand is localized to a small number of system components that implements the most popular system function. Yeah, so those are the problems identified with the software product that is addressing the user need. Of course, in the user need, you have scenario, stories, everything he wants to do, and a lot of things interacting in that product software. So what is the benefit of microservice architecture? Microservices are self-contained and run in separate processes, right? So they are just in their own container like that. So they don't have to be disturbed as much. Now, in cloud-based system, each microservice may be deployed in its own container. This means a microservice can be stopped and restarted without affecting other parts of the system. Now, if the demand on a service increases, service replica can be quickly created and deployed, right? So just as we have in the recent almost near collapse of the banking system with the use of their internet banking or web services, right? They have never envisaged that you were going to have so much traffic or volume of users hitting their sites like that, right? So if the demand increases for microservices, it could just be a little bypassing. Just okay, duplicate, get some things done easily. Now, of course, I was commenting on an article, and somebody was trying to excuse the negligence or the, well, let me not use very strong words. We're trying to excuse the banking industry that no, that the problem they were facing was because some of their IT personnel have traveled abroad. I said no, it was from the planning. Of course, I opined in the last lectures that you have people, at least maybe how many people are banked in Nigeria. Of course, most bankers have that information. Let's assume that 56 million people are banked in Nigeria. You should provide for at least 4 times that size, because people may have different kind of accounts because of the inconsistency in some of these banks. You could have interbank accounts or intra-bank account. For instance, individuals may have 2 bank accounts in First Bank. You have for current, you have savings. Then some people may have another one in First Bank, making 3 that they use for pure savings that they don't even have access to it, right? Now, some may also have interbank account. You have in First Bank, Zenith Bank, Access Bank, GT, and those other banks, those funny banks. So why don't you make provisions for that? Of course, it may be like a form of redundancy at first, but now it will come to a time that you have to face it either ways, right? And if plans are made, at least you're not going to be paying for it. It's the customers that are paying for it. You're not using your personal money. You charge me for card maintenance. I don't know what you're maintaining in the card that I'm carrying about, right? And you are charging me for, and you failed just to scale up. You failed, and you are trying to exonerate yourself. Well, I take very serious exception to that anyways. So let's look at an example. Now imagine that you are developing a photo printing service for mobile device. Now, we want to reason out how we can develop services, microservices. Now, this is one that you can just say, okay, photo printing, you may feel that that's a microservice, but you must look at the description, right, of all these, of what is to be done or what is to be achieved. Now, users can upload to your server from their phone or specify photos from either Instagram account or from their Instagram account that they would like to be printed. Now, prints can be made at different sizes and on different media. Now, users can choose print size and print medium. For example, they may decide to print a picture on a mug or on a t-shirt. The prints or other media are prepared and then posted to their homes or to their home. Now they pay for the print either using a payment service such as Android or Apple Pay, or by registering a credit card with the printing service provider. So you see that just this printing service has a number of microservices that could be derived from it. So you may just feel that printing is just all, and you just microservice like that. You find out that you have a lot of other things that you have to battle with. For instance, you are doing your research work. Say, after all, it's a research work, and you say, no, that's a microservice. No, in your research work, you have different segments. You have the front page matter, right? You have the introduction, you have the review of literatures, you have the methodology, you have the results, right? You have the conclusions, recommendation, and future work. You have the reference section, you have the appendix, and a host of other things. Even in all of these, in front page matter, you have the certification, you have the front page, you have the table of content, abstract, list of figures, list of table, dedication, plenty things. In the acknowledgement, you have different things. So each of these could be microserviced even for that. But the good thing is that some of these things can be grouped together or microservice because they are addressing the same thing. Okay, so this the microservice of that printing. So you have the service provided, registration or authentication, upload from Instagram or from anywhere. You pay when it is delivered, you print, and you have a dispatch. So let's look at how can we now decompose features or decompose activities into microservices. The first one is to balance fine-grained functionalities and system performance. Now, single function service means that changes are limited to fewer services, but require service communication to implement users' functionality. This slows down a system because of the need for each service to bundle and unbundle messages sent from other services. Now, follow common closure principle. Elements of a system that are likely to be changed at the same time should be located within the same service. Now, most new and change requirements should therefore only affect a single service. Now, I'm sure you are conversant with the clean closure, right? Is it in language or something? That's in compiler construction. So it should follow a principle of clean closure. And what it means that it belongs to the same category, right? That's, I don't know which example we can give. For instance, you have, okay, what happens in the body? For instance, you want to maybe consume food, right? Now, you could microservice things that help you consume food or that help in the process of consuming food in your body. For instance, you have the teeth, the mouth or the hand pushing the food in the mouth, the teeth chewing, the tongue tasting, the gullet swallowing, the small intestine, big intestine, this. So they could have different services, but of course, there will be interaction. So each of these part of the body could be microserviced, right? And they can now have different levels of interaction. For instance, you cannot have that your hand is interacting with your small intestine. How did it get there? Did you choke your hand in your mouth and it gets down to your intestine? How? But you could say that your gullet, that's your throat, can have a direct communication with your stomach. Then your stomach will now serve which one works for? Is it the big intestine or the small intestine? Right? Like that, like that. So associate services with business capabilities. So a business capability is a distinct area of business functionality that is responsible of an individual or a group. You should identify the services that are required to support each business capability. You should also design services so that they only have access to data that they need, not just like I just said, and cannot be choking itself into the intestine. I don't know what it's looking for there. Now, if there is an overlap between the data used by different services, you need a mechanism to propagate data changes to all services using the same data. We're going to look at this in detail. So these are the key design questions that you look at when you are designing microservices. Now, how do you communicate when you have several services? So services communicate by exchanging messages, right? For instance, the small intestine, no, the throat or the gullet takes food from the mouth to the stomach, right? So there's a kind of communication. Of course, I may not be an expert in that area, but there should be a kind of communication from the throat. Like maybe the throat will tell the stomach, open, food is coming. Then it drop the food, boom, 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 in the stomach, right? So the stomach close up so that air will not fill the stomach. Else, it would have been good that if the stomach can perpetually remain open, if you're hungry, you just open your mouth, then air will maybe quickly flow into your stomach and it's full. You don't need to be hungry or in need of food. So there's always a form of, communication style. So service communication by exchanging messages that include information about the originator who is sending the message, as well as the data that is the input to or output from the request. Now, when you are designing a microservices architecture, you have to establish a standard for communication that all microservices should follow. Some of the key decisions that you have to make are, should services or service interact by synchronous or asynchronous means or methods? Now, I'm sure you'd have done that in some computing courses, lower level computing courses, asynchronous transfer and synchronous transfer. Of course, we're going to look at it a little bit. Now, should services communicate directly or via message broker? Now, should you have direct contact with me, or should that be a middleware or a middleman? For instance, I found out that once I used the ATM of some banks, that I think they have something like intersettlements. Well, I'm not too sure. Somebody was trying to educate me during the defense that there's a kind of there's an intermediary that sends some data to the bank, then they do reconciliation and all that. So you should also decide, okay, if I send money from bank A to bank B, should it go directly to bank A where they can deny that they didn't see the money? Or should somebody keep a log that, okay, this money got here, so we are going to now relate the money to this bank, so that if that bank denies that, oh, I didn't see the money, we will trace it back to that middleman. He tells us that, okay, the money got here and I've sent to bank B, but the bank B is denying that I didn't get to them, and can take them to court. So what protocol should be used for message exchange between services? So you could develop protocol for this sending. So let's look at some of these communication um, methods or architecture. So what is synchronous and what is asynchronous interaction? So in a synchronous interactions, for instance, if service A issues a request to service B. So what happens is that service A suspends everything it's doing while it's waiting for service B to respond to its request. So service B will continue to, maybe it's processing. So service A will stop everything it's doing while waiting for service B. Now, if the processing in service B, when service B is processing, let's assume that service B is very slow. Now, that may be an issue, right? Especially when it has to deal with bandwidth, processor power, and a host of other things. So what it does, it will wait until service B has returned the required information before it continues processing or continues execution. However, in an asynchronous interaction, service A will just send its own request, right? So it is queued. When it gets service B, it will queue up. For instance, I'm sure some of you have sent several documents to your printer to be printed. So you just see one tax manager will just pop up and show you the number of documents you have sent to the pool, right? So they just queue up. And once one is completed, the other moves in to be printed. So this is exactly what happens, right? It queues up in B. Now, A can now still just continue to do its work, but continually check, okay, has this guy returned my request? Has this guy returned my request? So what happens, service B later sometimes will complete the request, send it back to service A. The service A checks and can now update what service B, or at least make use of what service B has sent back as a response. So these are examples of, or this is a diagram for synchronous and asynchronous microservice interaction. So we want to look at direct and indirect communication. Of course, in the opening, we said you could decide to have direct communication with a bank, or you decide to have a middleware. No, direct service communication requires that interacting services knows each other, right? So for instance, if I need to maybe pick up maybe something from somebody, I can just, because I know this person, I can go directly to the person and pick it up. But if I need a referrer, right, I need somebody to write a reference for me to somebody that he knows. That can be a form of indirect communication. So the services interact by sending requests directly to these addresses. So you know the address, you can send directly, and the receiving person also knows you. Indirect communication involves naming the service that is required and sending that request to a message broker. So the message broker reads, okay, this is where this guy wants it to be sent, and it sends. Now, the message broker is then responsible for finding the service that can fulfill the service request, right? It's just like, is it in grid computing? Then when researches were going on in grid computing, of course, this was one of the issues that we had to deal with for grid computing research. So this for direct and indirect. So microservice data design. Now you should isolate data within each sharing as possible, right? So if there's going to be any form of data sharing between services, it should be minimal. Now, if data sharing is unavoidable, you should design microservices so that most sharing is read alone or read only. Now, why do you want to have read only data sharing is because of inconsistency. Now, for instance, when we looked at asynchronous and synchronous sharing, right? We saw that, okay, this individual is sharing, okay, is requesting something, and maybe service A is requesting something from service B, and service B is just there doing his own work and doesn't even mind that something is queuing up for him to be processed. While service A is still working, and maybe after some time, when service B feels is now okay, he responds, and maybe some other services have updated the database. So there's a tendency for inconsistency in database. But if data sharing is minimized or reduced to the minimum, right, it helps so that, okay, if service A has to wait for service B and service C, you know that it's just these three guys that are interacting on this data, right? So a possible solution is to keep a data log, right? So that somehow you could do what we call a rollover or a rollback. So if data sharing is unavailable, you should design microservices so that most sharing is read-only, which is locked, right? With a minimal number of services responsible for data update. Now, if services are replicated in your system, you must include a mechanism that can keep the database copies used by replica services consistent. So how do you now manage these inconsistencies? Now, an ACID transaction bundles a set of data updates into a single unit so that either all updates are completed or none of them are. So ACID transactions are impractical in a microservices architecture. The database used by different microservices or microservice replica needs not be completely consistent at all times, right? So dependent data inconsistency. The action or failure of one service can cause the data managed by another service to become inconsistent. That has to do with dependent data inconsistency. Then replica inconsistency. There are several replicas of the same service that are executing concurrently. They all have their own database copy, and each updates its own copy of the service data. You need a way of making these databases eventually consistent so that all replicas are working on the same data, maybe at a later time. So when you have replica inconsistency, there should be at least a time when all the data can now be consistent. So eventual consistency is a situation where the system guarantees that the database will eventually become consistent. Now, you can implement eventual consistency by maintaining a transaction log. Now, I'm sure some of you who work in a bank or where you have repository, right? You work with logs. So when a database change is made, this is recorded in a pending update log. And of course, it will tell you, okay, this young man updated this account at this time, right? So all this information will help you in updating that database accurately. Now, other service instances look at this log, updates their own database, and indicates that they have made changes. So how is that represented? You have service A working on database A, service B working on database C. So service A1 updated database, updated database 1. A1 updates database 2, A2 updates database. So all these logs will now be used to achieve eventual consistency. So If we are going to have eventual service consistency, how do we now coordinate the services? Most user session involves a series of interactions in which operations have to be carried out in a specific order. This is called a workflow. So an authentication workflow for UID through password authentication shows the steps involved in authenticating a user. In this example, the user is allowed 3 login attempts. The system indicates that the login has failed. So when you tried 1, 2, 3, then you can be logged out. I'm sure some of you have had to receive, is there still POC? There's this thing they call POC that MTN sends to us most of the time, that if you attempt to, I've forgotten, I've been blocked once or twice, that you want to change something and say PIN, enter PIN. You enter the wrong one the first time, second time, then they will ask you to contact your service provider for PUK. Then you go and line up in front of one rude attendant and be talking to you as if they are the ones who buy credit card for you, right? So I don't know if they still use that anymore. So this is the authentication workflow. So attempt 1 fail, to records fail, attempt 2 fail, records it, then it throws you out after you have tried the 3 attempts. So to get your login, check login, get password, check password, then end. But if the login it fails, it tells you that no, this attempt has failed. So if after the second login you get it right, it takes you to the next step. But after third attempt, so it tells the user, guy, this is not your account. You are just trying to get into another person's account. So orchestration and choreography service. So you have authentication controller, login service, password service, service choreography, login service, authentication events, password services. So what are the failure types in a microservices system? You have internal failure, you have external failure, you have service performance failure. For internal failure, these are conditions that are detected by the service and can be reported to the service client in an error message. An example of this type of failure is a service that takes a URL as an input and discover that the link is invalid. Excuse me. External service failure. These failures have external causes which affect the availability of a service. Failure may cause the service to become unresponsive and actions have to be taken to restart the service. And service performance failure. The performance of a service degenerates to an unacceptable level. This may be due to a heavy load or an internal problem with the service. So external service monitoring can be used to detect performance failure and unresponsive or unresponsive services. So, for instance, you log on to your mobile banking app, right? And or you have attempted to log in several times and you didn't or you couldn't, right? Then maybe because maybe somebody just calls you, you have something to do, you leave your phone. Now, I think I have that experience with my bank. You just come back to continue, just say this session is it out, or session, I forgot, they have a display that they just sent you that the session is out, or I'm not sure. But it's just telling you that no, you can't continue this session like that. So you have to re-log in with your password, right? That's even if you are working before and you got logged in successfully, then maybe due to something you just left. By the time you come back, you have to re-log in again. So a timeout and circuit breaker is important for at least controlling is a form of security measure, right, for controlling maybe sorry, the failures. So sorry, jumped again. So a timeout is a counter that is associated with the service request and starts running when the request is made. Once the counter reaches some predefined value, such as 10 seconds, right, the calling service assumes that the service request has failed and acts accordingly. Now, the problem with the timeout approach is that every service call to a field service is delayed by the timeout value. So the whole system slows down considerably. So instead of using timeouts explicitly, when a service call is made, we suggest using a circuit breaker. So like an electric circuit breaker, this immediately denies access to a field service without the delay of counting 10 seconds for every field request. So without the delay associated with the timeout, which has a defined amount of time. So this is using a circuit breaker to cope with service failure. So reset full service. Please, I would like to have maybe a few minutes. I need to get some water. I'm already parched. So please. All right, so I'm back. So the REST, representational state transfer architectural style, is based on the idea of transferring representation of digital resources from a server to a client. Now you can think of a resource as any chunk of data, such as credit card details, an individual medical record, a magazine or newspaper, a library catalog, and so on. Resources are accessed via their unique URL and RESTful services operated on these resources. This is a fundamental approach used in web where the resource is a page to be displayed in the user's browser. Now, an HTML representation is generated by the server in response to an HTTP GET request and is transferred to the client for display by a browser or special purpose app. Sure, you do this all the time. You type maybe www something Google. So a request is sent, then close Google for you to search for, probably you're searching for journal or something. So RESTful service principle, use HTTP verb. So the basic method defined in the HTTP protocol is get, put, post, delete. Now, I'm sure you be used to some of these words. Okay, I don't think I'm supposed to teach this now. So must be used to access the operations made available by the service. Stateless service. Services must never maintain internal states. And already explained microservices are stateless, so fits with this principle. URI addressable. All resources must have a URL, sorry, with an hierarchical structure that is used to access Can you still hear me, please? Oh, okay, thank you. I thought I was talking to myself when I didn't see anything. Use XML and JSON. So resources should normally be represented in JSON or XML or both. Other representations such as audio and video representation may be used if appropriate, like a voice command and everything. Okay. Oh, okay, thank you. So RESTful service operation, you have create, read, updates, and delete. Okay, response. So for create, so implemented using the HTTP post, which creates the resources with the given URL. If the resources are has already been created, an error is returned. Read, implemented the HTTP get, which reads the resources and returns its value. Get operation should never update a resource, so that successful get operation with no intervening put operation always return the same value. So if you send in a get, it's just like for instance, you want to query an ontology, right? So once you send in, okay, you are looking for this knowledge class. Now, you're not expected to do any form of updating on the ontology. It's just for you to get maybe the RDF or the web ontology or the semantic web ontology representing that knowledge domain, right? So you just read. Please. What's the difference between put and post? Okay. Now, posts, for instance, you create a kind of a form of resource and you want to host it or you want to display it. So displaying it or hosting it is posting it online. Let me just use that word. So put is that you have already created a content. However, at your own end, you have done a bit of modification, right? You know, you have posted, let's assume you posted, let's say you posted A, B, C, D. Now, maybe at your own end, you have put E in order to make that reflect on the initial post. You have to put what you have edited on the already posted documents. Does that make any meaning? Or does that explain in a layman's language to you? Okay, I'm waiting for a response. So read. So implemented using the HTTP gets, which reads the resources. So once you have something running, just as I just said in, for instance, when you have developed a knowledge ontology using a ProtoGL, right, you can now maybe get whatever you want. Of course, is a represented knowledge using the semantic web, semantic web language. You could get whatever in not a domain knowledge that you have that has already been posted from the semantic whole. That's am I even communicating? Or am I too well? Sorry. Let's use a simple term. For instance, you have documents online. So you want to retrieve it. You want to search for a document. That is get, right? So updates implemented using HTTP put, which modifies an existing, oh, this is even here. It modifies an existing resource. Put should not be used for resource creation, but for resource modification. Yes, sir. That means put is like an update. Okay. Who is this Stanley again? Okay, don't worry. Yeah, I can see that you have not learned. Let's say I didn't tell you to put your name. You keep putting your name. I think it's because I've not even thrown you out. That's why you are still being stupid. Stanley Undano. Okay. All right. So, okay. Sorry, I was reading some chat before that. So, how will the error be identified under create? Okay. Sorry, Brian. Well, you are the creator of the content, right? So you may, maybe, for instance, you create a microservice and you feel that the user's need or business need has changed. So with that, that could help you. It's not necessarily an error. It's just like, okay, for instance, you are told to write an abstract when you had not finished your project. Normally, that should be a summary. But when you are done with your project, you find out that the tone of your summary will change. The tenses will change. So it's not really an error, but a form of modification to exist, to what you have written exists, what is already written. For instance, you use tenses like I will read or I will review existing literature. I will implement this using this. I will do this using this, right? But when you come back and you are done with your project, instead of you saying using reported or futuristic tense, I will, it will be changed to I did this, I did this. So that could be used to update. It's just like you, at least that's still on your Microsoft Word. You could have a copy of your chapters 1 to 3 having different English, then you could update it. So it's not that you have committed an error. It may be just due to um, maybe change in what has been done or change in business services. So I hope that guys are making me slow down. I want to be fast. Oh boy. So it's just a form of modification to an existing resource. So delete. So implemented using HTTP delete, which makes the resources inaccessible using the specified URL. The resource may or may not be physically deleted, right? Just making it read alone. Okay, I think there's a response from this person. Oh boy, moving on. So let's look at an example of all these plenty illustration. Want to use, imagine a system that maintains information about incidents such as traffic delay, road work that is to be commenced, accidents on a national road network. Now, this system, you could access it here. Now, users can query. So you can say get. That's when you want to query, right? You use get to discover incident on the road on which they are planning to travel. I'm sure you'd have interacted with, what's the name of this thing? Google Map. Yeah. Purely for those of you who live in high traffic areas in Lagos. So you could query the, you put your location, then you put your destination, then of course, it will just look around and see, okay, search for the best routes, then look at places that it feels that, oh, there will be a lot of traffic. We try to maybe allow you dodge, if I may use that word, dodge those areas. So it will bring up the best possible route or routes that you could take. So where there will be traffic, it will put red. Where there will be maybe minimal traffic, it will put some other color. So that's what you're interacting with generally. And you have been using some of these terms unknowingly. So just hearing it here, you're just putting it into perspective generally. So there's nothing I'm teaching that you do not know. All you are doing is putting them in perspective. So when implemented, a RESTful web service, you need to design the resource structure so that incidents are organized hierarchically. For example, incidents may be recorded according to the road identifier. For instance, a road A90, now the location, e.g. Stonehaven, the carriageway direction, e.g. North, and an incident number, e.g. 1. Therefore, incidents can be accessed using the URL http trafficinfo.net incidents A90 Stonehaven North 1, right? So this is just to get information about an incident with number that has been arranged hierarchically and given the number 1. So incident description, so incidents ID this, dates that, time reported this, severity, significance. So description, broken down bus or not carriage, one lane closed, expected delay up to 30 minutes. So this is what this is, you have sent get. So it brings this to publish for you to see, right? So service operation, retrieve, add, update, and delete, just as we have seen. So return information about a reported incident or incident, access using the get verb, add information about a new incident, access using the post verb. For instance, there's a particular radio program in Lagos. I'm not sure if I'm correct about the name. It's just reporting traffic situation. So they will call, you call where you are, you tell them that, look, guy, there's an accident here, or there's a road traffic this here. So you could report situation. So people around or going around to that region can decide to quickly run away. But if you have an app where you could quickly report that, you could use the verb add to post what is happening. Then update, if there's a difference in what has been happening. So update the information about a reported incident, access using the put verb. So you could superimpose what you have posted earlier in the software. And it's okay now. I think the last month officials, they have brought big trucks, they have removed that thing, and it appears traffic is flowing. So you update what you have posted. So delete an incident. For instance, if you have a fake news or probably you are not there, somebody just called you, hey, guess what? It's what they call these touts in Lagos. Forgotten what they call them. All those all those your people. So just say, oh, this TSSVK. What's TSSVK? I say I should put your name when joining. I'm going to delete you, this TSSVK. Thank you. You call them Magbiru. So if say Agbiru are fighting in this particular place and all that, so you could quickly delete if the information is not totally, or it's not correct, not even totally correct. So, and the funny thing about traffic in Lagos is that you could just, you've been in traffic for 2 hours, you just get to where the traffic is, and you don't see a reason where there should be any form of traffic. You just say, okay, them just passing. Maybe one guy just decides to sleep on the road and everybody is trying to avoid him. And that is the cause of traffic in Lagos. So these HTTP requests and response, you have HTTP requests. So the microservices will be request processing, service action, response generation. So when that has been packaged, then the response is sent to you. So this is okay. You have an app, request the traffic from Yaba to Aja, right? So you type something, That's a request. So the microservices are processing they process your request. You look at, okay, what actions is this supposed to perform? Okay, check the route, check what is happening on the road. It will generate the report in a particular format and send the response to you. So how does it? So HTTP request and response message organization is done this way. You have HTTP request verb, you put the verb, maybe get, you have the URL, then HTTP version, then request header, the body. It is sent to the microservices, then the response is prepared at HTTP version response code to you, response header, then the situation as it were. So this is the XML and JSON script. I'm coming, there's a question here. Might just be a bad course. Oh, goodness me. Pikel Omore, and what you say is it might just be a Agbalumo causing traffic. Oh, goodness. You know, Lagos is a funny place. So this is XML, just some script for that. This is the XML for the description and all that. So this is what you get. Put whatever you need, then the response is sent to you that on this route, on this road, there's this thing, grass cutting, or veg minor, or it could be that an individual is selling agbalumo, and the person who bought agbalumo doesn't have cash, so it has to come with POS, and the POS, the POS is not this, is not going. Maybe something declined. Then that's so the file just starts. So this is a format. So all these things we have been saying is just here. You send in a request, you type, okay, what's happening around this place? Then the response is sent to you. Excuse me, please. So service deployment. So after a system has been developed and deployed, has been developed and delivered, it has to be deployed on servers, monitored for problems, and updated as new versions become available. This is another good English to use. So when new versions become available, you know, when we're looking at the agile process, we saw that, okay, we'll be doing increments. So in updating, it may not be that an error has occurred. It may just be that maybe a technology has changed, right? Or a business approach has changed, or a new software has come up, right? I think recently we're trying to develop an ontology for what we're trying to develop an ontology for COVID and Ebola, right? And of course, we're able to develop the ontology on the standalone PostGL, but we wanted to make it a web-based whatever. We wanted to make it web page. So we just found out that the plugin that we're supposed to use wasn't available. So we had to look for another route in solving that problem. So maybe just that the business model for the software you're using before has become maybe laborious to you. You can decide to opt for an increment or a change. So it may not be an error necessarily that cause you to change. So the service, so when a system is composed of tens or even hundreds of microservices, deployment of the system is more complex than for monolithic system. Monolithic means big system or gigantic system. So the service deployment team decides which programming language, database, library, and other support software should be used to implement their service. Consequently, there is no standard deployment configuration for all services. It is now normal practice for microservice deployment team to be responsible for deployment and service management, as well as software deployment, and to use continuous deployment. Continuous deployment means that as soon as a change to a service has been made and validated, the modified service is redeployed. Can we call subdomain microservice 2. That's too large now. Let me call it microservice. Sorry, I'm responding to a question. Someone said, can we call subdomain microservice 2? Well, it depends on what you call a subdomain. But for me, when you say something is a subdomain, it means something very big, especially when you are talking about networking, right? Something very big. So even a feature that is just very little cannot be called a microservice. All right. So deployment automation. So continuous deployment depends on automation so that as soon as a change is committed, a series of automated activities is triggered to test the software. If the software passes this test, it then enters another automation pipeline that packages and deploys the software. So the development of a new service version starts with the programmer committing the code changes to a code management system, such as Git. This triggers a set of automation tests that runs using the modified service. If all service tests run successfully, a new version of the system that incorporates the changed service is created. So another set of automated system tests are then executed. If this runs successfully, the service is ready for deployment. So this is a continuous deployment pipeline that's this plenty English has been talking about. All right. So you have a service request, API gateway, monitor response, camera, current link, camera 2, service response. So this is just like trying to create microservices for a camera response service. It's just a simple example. So what are the key points from this lecture? So a microservice is an independent and self-contained software component that runs on its own process. I'm sure you still remember the, what's this thing? When we did containerization, still remember that, right? So that runs on its own independent processes and communicates with other microservices using lightweight protocols. Microservices in a system can be implemented using different programming language and database technologies. Microservices have a single responsibility and should be designed so that they can be easily changed without having to change other microservices in the system. Microservice architecture is an architectural style in which the system is constructed from communicating microservices. It is well suited to cloud-based system where each microservice can run in its own container. So the two most important responsibility of architects of a microservices system are to decide how to structure the system into microservices. So that's one of the responsibilities that you have to do. And to decide how the microservices should communicate and how they should be coordinated and how they should be deployed. So these are the 4 responsibilities that you are going to be assuming very soon. Oh boy, I'm tired. Communicating and coordinating decisions include deciding on microservice communication protocols, data sharing, whether services should be centrally coordinated, and failure management. Thank you, Mrs. Oyelade-Rose. The RESTful architecture style is widely used in microservice-based systems. Services are designed so that the HTTP verb get, post, put, and delete maps onto the service operation. The RESTful style is based on digital resources that in a microservices architecture may be represented using XML or more commonly JSON. Can we use RDF too? I don't know, but maybe we'll do that as an assignment. So continuous deployment is a process where new versions of a service are put into production as soon as a service change has been made. It is completely automated. It is a completely automated process that relies on automated testing to check that the new version of the product of a production quality. Now, if continuous deployment is used, you may need to maintain multiple version of deployed service or services so that you can switch to an older version if problems are discovered in a newly deployed service. So that's what we call backward compatibility. So I think we have come to the end of today's class. So this is about the record time that I'm finishing the class. So thank you for your time. Thank you for your attention. So we're going to have assignments now, and the assignment is going to be submitted latest by midnight tomorrow. So what's going to be the assignment? So while we are listening to the assignment, can you start putting down your name and your matric number? You can see some people are just running to join now. Now we have 128 candidates and a number of other people are rushing to join now. I think I should block the class from anybody joining now, because that's a criminal offense. You didn't join the class. Now you want to write your name and run again. All right, so the assignment. So look for a domain. One, look for features in that domain that can be self-organizing. Then break those services, break those features into microservices. Now, remember the rules of using microservices, right? Get a domain. Now, when you get a domain, look for features that can be implemented in that domain, then break those features into microservices. So you have like you just like you're developing an architecture, right? You have a big name, right? That's a big topic. Then you have features, like you just have arrows coming out of it. Features. Now 3 people are joining the class already. Okay. You have features coming out of that. Then out of those features, you can now start breaking those features into correlatable microservices. So what you do is this: you are going to get a sheet of paper, you write your name, your matric number, you will use your pen and pipe, whatever, to draw it, you scan it, and you upload to the email provided. Now, Mr. Olanite, please, I need you to maybe get, or is there a way you can get the list of all registered students? Now, I'm going to be downloading the list of registered students by next week. So if you are not registered, please don't join this class again. You are giving me a lot of trouble. During the test, we have almost 180-something students. Only 120-something submitted assignments. So how do I provide resources and you are misusing it? Yeah, I'm not having time for you to just start making, you are coming to class for free. No, you should not come to class for free. It takes somebody's strength to get the class done, right? So that's the, excuse me, that's the assignments that you will need to do. Recording, yes.